Welcome back guys for the UGC lecture series on laser applications under Swayam portal. Now we are going to see another technique of measuring the distance employing lasers. In this case it is going to be a long distance. For example, if I want to measure the distance between India or Chennai and a satellite up in the sky, I would be easily using this technique. What I need to do is very simple. If I have a high power laser in one of the laboratories and if it is a pulse laser, all that I need is very simple. I start with the laser, put a small mirror. This mirror will reflect a very small quantity of light to a photo detector, which can be connected to an oscilloscope. So, there will be a signal coming from the first mirror. Then another part of the laser beam will go here. It should be just, let us say it just comes here, put a mirror, this mirror sends the light up to the satellite. In the satellite, imagine that you have a big mirror. That mirror will capture this light and reflect it. That light, if it is properly aligned, that light will come back a little here. To do this, to capture the light from the satellite, remember you must have a big telescope arrangement, big lens, whatever it is. What is important is if you could gather the light from the satellite from using the big telescope and then send back the light back to the same place, then you can immediately measure the distance, because the light has left here. This distance is, let us say, 5 centimeter. It has come out, gone up few kilometers, maybe 20,000 kilometer, 30,000 kilometer distance, and then it goes and comes back. Let us say this distance is L and another distance L. So, the time difference between the pulse from this mirror and the pulse which comes back after traveling all the way up to the satellite, you can easily, if this is delta t is a time difference, then the light has traveled a distance of length L. So, 2 L over c, c is the speed of light. Then immediately you know what is L. That gives you the distance between, let us say, Chennai and any satellite which is going up. Is it possible? People have done it so many times. People have done even the measurement of moon, starting from moon, the distance between moon and earth has been measured employing the same idea with more sophistication, more signal amplification. There are so many improvements, but the idea is as simple as that. For that, for example, people have used, I think for when Armstrong landed, I think in 2090, I think Armstrong left 1969, if I remember correctly, I am not very sure. Before that, laser was there, ruby laser was already there. So, they employed a Q switch laser. When Armstrong went there, he left a corner cube prism, big array, so that some light at least will catch. He made, then from here, from USA, they sent a very powerful pulse of Q switch laser. It went up to that, went up there, remember you would have spread out, then it came back. That light could be captured using proper telescope. Remember, these days telescopes are very capable of, even from a distance Mars, distance galaxy. Moon is so close to us, it is very near to us compared to what is being done. It is nothing, it is a very small distance. Then collect the light, then you do the same measurement. This gives you the distance between earth and moon with an accuracy of 1 parts per million. Such an accuracy is possible. Remember, all these things are much easier said than done. because the light that goes out, the light that comes out undergoes so many changes, refractive index changes, and in between you have earth. In the earth you have so many vapor, so many dust, so many moisture, so many things are there. Now you must take care that all these inaccurate sources, I mean problem creating sources, are carefully eliminated, and if you repeat this experiment over few times, few hundred times, whenever you get a consistent result, that means that's a correct measurement. This kind of light detection and ranging is called the LIDAR, which is a modification of a radar. Radar is a radio wave detection. LIDAR, radio wave detection and ranging. Radar means RADAR, radio wave detection and ranging. What it means is, it detects an object and measures the distance, then only it is called radar. Where have you come across radar? You must have heard about it. The First World War was won by radar. Why we say First World War was won by radar is something like this. British scientists, they were able to design this electronic instrument where they could produce radio wave. The radio wave was just projected up into the sky. When this radio wave goes, and if there is a flight, enemy flight coming from, let us say from Italy or from Germany, they could be detected at a distance of few hundred miles, because radio wave goes and comes back. The time difference, the light wave, radio wave is like a light wave, it is an electromagnetic wave. Speed of the radio wave is same as a light wave, 3 into 10 power 8 meter per second, or 3 into 10 power 5 kilometer, such a long, very high speed. So even if the aircraft, enemy aircraft just goes up the sky in Germany, when it reaches the horizon of UK, United Kingdom, even when it is at a distance of 50 kilometer, it can easily detect that there is a object coming towards you, and you can keep on measuring 10 times, then you can measure the time difference, then you can say this particular flight is coming towards you or going away from you, because the time difference will keep on changing. From this you can find out, all this can be pictured. This is what is being done in today's flight. In every flight you have the radar. Without the radar, these days you must know there are at least few million flights are going back and forth throughout the sky. All of them are based on radio wave detection and ranging. They employ radio wave, not the laser. On the other hand, employ the same principle. Instead of radio wave, use a laser. If you use a laser, you can detect one point. The difference between radar, radio wave and laser is, radio wave is not very directional. It will go as a wide beam like this one, whereas laser will go in a straight line. So to capture only one particular object, LIDAR is the best. To capture any object anywhere in any part of the big sky, if you are exploring what is coming and where is it coming in a big, you don't know where is this coming, how far is it coming, in the north or south or anything, use a radar, keep on sweeping like this one. Somewhere you can catch that another enemy flight is coming here from the east or from the west, wherever it is, and you can precisely calculate the speed and angle, then keep the gun ready, shoot it. This is how they shot the enemy plane, and then British UK won the war. So, the credit goes to radar. Now, we come back to laser. LIDAR uses a very similar technique. It measures very distant object like a moon. It has so many other applications also. We will not go into the detail. Now, what is very interesting is, I will just switch over to this one. We will come back to this one, come back to what we said later. You must have heard about laser Doppler velocimeter. Once upon a time, it was a big fancy. Now, it is not a big fancy. Why? I tell you, if you go to any hospital, if your parents are in the age group of 60, 70 or 80, they would say that I am not able to walk and I feel some problem in the leg, something. What, there are so many reasons. Then the doctor would say, go to the diagnostic center, measure Doppler, get me the Doppler measurement of blood flow. Then you must go to the hospital. I have never done it. I don't know how actually it works. Only possibilities, they will shine some kind of laser, tie up somewhere, then the blood flow would be restricted. When the blood, I don't know how actually it works, but the idea is very simple. When the blood is flowing through this, if you shine a light, then if the velocity, when it comes here, we can easily measure the fluid velocity using this formula, because we know what is the frequency of the light wave. The light that falls on the blood flow will produce a certain shift in the frequency. From the shift in the frequency, you can measure the speed with which the fluid is flowing. That is all the idea of laser Doppler velocimeter. Now, velocity of fluid is given here. Look at this one. Lambda naught represent the wavelength of the laser used. N naught is the refractive index of the fluid. For example, for blood it is about 1.4 or 1.5. The refractive index of water is 1.33. For blood it may be 1.45 or 1.5. I have never measured it, but it should be somewhere around that region. Now, blood is, I mean, you can see the liquid. It may be any liquid, it may be blood or it may be water, it may be a gas or anything. You see the long tube, this is where some fluid is going. You have a laser on the left side, then beam expanded laser, which also I already explained, that goes, and then the next lens, the third lens there, which focuses the laser beam on a tube or a chamber in which some fluid is flowing. Let us say, take for example, blood in the hospital. Then it will be falling at certain angle. Then if this is falling at an angle, the light intensity will be shifted in its frequency because of the Doppler effect. I can explain what is a Doppler effect in 2 minutes. Imagine that I am standing here, standing in the platform of small town. I am safely standing in the platform. There is a Vande Bharat train coming from, let us say, from Madurai or something. It will not stop here. Remember, it will not stop here, but it will just fly past this one. Then if I keep myself safe at a distance, listen to the speed and the sound of the train coming. As the train comes, cuts through and passes through, let us imagine, when it comes near me, towards me, the frequency produced, not the intensity, the frequency produced by the mechanical movement of the train will keep on increasing. When it comes, it will be the maximum. Then as it moves away from me, the frequency will decrease. This is called a Doppler effect. Another example, I am standing in the road somewhere in the safe place. You must have seen some boys use some bike which makes enormous noise, that kind of sound. Next time you can do this experiment, stand at safer distance. When they come at a long distance, when they come towards you, if you listen carefully, as they come, the frequency, not the intensity, the frequency will increase. When they come and pass by, the frequency will decrease, the sound. Not the sound, frequency. This is called the Doppler effect. This particular Doppler effect has enormous application. This is what it showed, that the whole universe is expanding. Now, I am not going to the detail of all this one. What is important is this particular speed of any fluid. It may be air, it may be a gas, it may be a water, it may be blood. All this, the flow velocity of any liquid in any tube can be measured using laser beam. The shift in the frequency of the laser beam, the formula used is this. The velocity of the fluid V is delta nu d is a shift in the frequencies given. That is called Doppler shift in frequency. Lambda naught represents the frequency, in fact wavelength of the laser, it is given. N naught is the refractive index of blood. 1 over 2 sin theta 2, theta represents the angle with which the liquid and laser interact. Imagine the liquid is going through this one. I put the laser in this angle is called the theta. That is all. If I measure all this one, then I can easily find out the speed with which blood is flowing through the blood vessels. This is a very, very important measurement technique commonly used in all our diagnostic center, and all hospitals will have this one. This is called the laser Doppler. This is based on this principle. Another interesting, nowadays suppose you are driving a car, or if you are driving a motorbike in a road, important road, you must have seen some warning signal. Your car is driving at the speed of 60 km/h, reduce the speed. In USA or in any western countries, they do not give all the warning. They would say that the speed limit in this area is 60 miles/h. Then if you go very fast, they will not say anything about it. They would easily use this laser Doppler measurement technique, take a photograph, then that camera will take your vehicle number, car number, then they will send a ticket straight to your account. They will detect some $100 because you have overspeed in this place. How do they do? Just measure the frequency, as simple as that. They send the infrared light on the car will just reflect the light comes back, and then it will produce a certain change in the frequency. Change in the frequency will easily measure the speed with which it comes. Now, here is something interesting. The velocity of the fluid can be measured accurately if the wavelength is bigger. If the wavelength is bigger, if I use infrared or high infrared, let us say 1500 nanometer, such lasers are easily available. If I have 1500 nanometer better than green or red, it is easy to detect. Not only that, if it is a green or red, the people who drives a car, they know there is a red light coming towards me, so I will reduce the speed only at that point. Then I can escape. But if it is infrared, I will not be able to say. So, I will send the infrared light on my car. It will keep on detecting without ever knowing. I will come to know that in this point, between these 2 points, I have traveled at 70 km/h or 80 km/h. Correspondingly, the fine will increase. Once I come to know about the fine, I would be cautious all the time to be traveling with 60 km/h. That is all the idea. That is the main idea of this one. which has been very systematically used throughout the world, and thanks for laser, thanks for laser Doppler technique also. Now, going back to another important thing, we will now see remote sensing. This is another very major application. You know, in our university, we have a big remote sensing center. There they employ variety of waves. It may be a radio wave, microwave, each has its own advantage. Now, people use laser beam for remote sensing. What are the advantage? Laser can penetrate a longer distance. I mean, if you want to focus and see what is happening in a limited area, laser is the best. On the other hand, for example, look at this one. If you want to see what is happening in the bottom in the small area, the best one is have a flight. Forget this flight. These days you can have a drone, then send the laser beam, send a linear laser beam. All that you have to do is put a grating. When you have a grating, you will have spread out laser beam. Very simple, as simple. Then you just sweep across. Then you can, the light that comes back can be monitored on the top. You can do photography, you can do color photography, there are infrared photography, there are so many techniques to process the signal coming back. Then you can have the complete up and down everything about the terrain below. This is called the remote sensing. Next point. If it is a sea, use the same technique, just to sweep across. You can find out where there are fishes, where there are fungus, where there are oil slick. Imagine some time ago there was some kind of mishap. A big ship, oil container, oil tanker, just did some leak, and the whole area become slick with oil. This happened even in North Madras. When such a thing happen, all that you have to do is use this kind of technique, drone with a proper laser, then sweep across and find out from which area to which area oil slick has spread out, and then give up. Just usually the company which this one will have a heavy fine. They pay for all cleaning up this oil slick. All these things are very, very common examples of laser remote sensing. Now, we use another important thing was, suppose I use the infrared laser on the top of it, very powerful infrared laser. It can penetrate below the surface. If there is a hidden monument below, it will reflect, it will show. I can use radio wave, I can use microwave, or I can use light wave. You have laser in all wavelengths. So, depending upon my requirement, I just sweep using one end to another end, and if I keep on sweeping, if there is a hidden monument at the depth of 5 feet or 10 feet, it will show up there is something unusual, unexpected feature. It may be a hidden archaeologically important monument, or it can be a hidden city may be there, we do not know. So, it will show there is something interesting. Then it will go to the next step. This is what you call remote sensing archaeology. Then they will come down, the professional archaeologists come down with a small ground penetrating radio wave detector, which will slowly roll through and localize, find out that this is the place where there is a hidden monument, or there is a oil, or it may be some waste, I mean water pipe that was laying there under this has broken, or electrical pipe has something, whatever is wrong, they can be detected using this kind of laser radar drone with laser. This can be done. This not only can be done, it is being done every day. It is a very common thing these days. Okay. This is another very interesting thing. In the plant, you can do laser remote sensing. For example, you have a big forest. In a big forest, there is some other point, some small places where there is some disease for the tree. Send a laser beam, just keep on scanning. Imagine that up to this it is very, very green. Suddenly there is something wrong, there is nothing there. If there is nothing, tree is not growing there. Why tree is not going there? If you localize this point, if you can go and dig it, maybe you will find a city or a civilization hidden there. This is how a pyramid was recently detected in Egypt. It all happened about 2 or 3 years ago using laser remote sensing, and then the archaeology will go and do further studies. This is for laser archaeology, laser based remote sensing archaeology. The same thing can be used for detecting an infectious disease for the trees. You all know that if you have an onion or a potato or a tomato, for some time they will have some fungal infection, and then when they are close together, one potato will spoil the other one also, something like we spreading our own infection to others. Then when such a thing happens in a big forest, a large amount of trees will get affected. To avoid this one, we employ laser, identify a small region where the trees got infected, locate it, go and take a proper measurement, proper arrangement to spray chemicals or anything, and try to localize the disease. For this one also, laser remote sensing is employed. There are many more techniques which we will see in the next few lectures. Thank you very much.